Metallic bonding. So most compounds are held together by either ionic or covalent bonds, or some combination of those two. Like if I had something again like my magnesium sulfate, the SO4 here, ion, the sulfate ion is held together by covalent bonds, but it has a -2 charge. Magnesium has a +2 charge, so it's an ionic compound, but then this polyatomic ion here is held together with covalent bonds. But there's also metallic bonding. So a metallic bond occurs when our valence electrons are shared by all atoms in a compound. So basically you end up with this sea of electrons that surround these positive ions here. So maybe these are copper atoms. And the copper atoms are donating their electrons to this sort of sea of electrons out here. And the copper atoms, which have a positive charge now, are attracted to that sea of electrons. So what this does is we have all these electrons that are not really attached to any particular atom. This allows metals to have a lot of their properties, such as conducting electricity, such as conducting heat, such as being bendable. Okay, so this allows metals to deform easily. It's why they're considered malleable and ductile. Okay, malleable means you can make flat sheets out of it like foils, like aluminum foil. Ductile means you can make wires out of it. So again, these atoms are not bound tightly to other atoms, but they are bound fairly tightly to the electrons, but the electrons can flow. So the metal atoms can kind of flow around each other a little bit, which makes, again, allows the electrons to flow so you can conduct electricity, makes them malleable, makes them easy to bend and form.